For this warm-up, you have a chart to complete using fact families. So there's 2 multiplication facts and 2 division facts for each fact family. The first one is done for you as an example, and then I will do another one also for you to see. Here we have 4 times 10 is 40. Another multiplication fact we could use is 10 times 4 is 40. Then for the division, 40 divided by 4 is 10, or 40 divided by 10 is 4. So we're using those same 3 values to write multiple pieces of the fact family. Please complete the full chart for your warm-up. Make sure you include problem 1 also, even though it's done for you. For problems 1 and 2, complete the table for the given division statement. 4 divided into 2 equal groups. That would be 4 in each group. You can see here on the number line, 4 and 4. And so our division expression, 8, was divided into 2 equal groups. Number 2 says 8 divided into groups of 4. So if it's divided into groups of 4, there's 2 groups needed to make 8. So again, 4 and 4, that's the size of our group. 8 divided into groups of 4 gave us 2 pieces. You can see if it asked for 8 divided into 4 groups, then we would have 4 groups of 2. But it asks for groups of 4, not 4 groups. That's why we had 2 bonds here, and we would need 4 if it asked us to create 4 equal groups. Here we have -8, and we're looking at how you could visualize dividing with negatives. So -8 is split into 2 equal groups. The division expression that would match this problem is -8 divided by 2, because it's split into 2 sections of our number bond. And that would be -4 and -4. 3, consider the number bond. Which students have given a correct division expression and use correct reasoning? Circle all that apply. Sarah thinks the number bond represents -8 divided by 2 because -8 is split into 2 equal groups. That is correct. That's the one that I mentioned. Dylan thinks the number bond represents -8 divided by -4 because -8 is split into groups of -4. That also works. Lily thinks the number bond represents -8 divided by -4 because -8 is split into -4 equal groups. That one doesn't really work. If you had -4 groups, that one might be a little trickier to draw. Problem 4. Complete the number bond and number line that represents the division expressions. Then complete the table. Well, -8 is split up into 4 different bonds. If I split 8 into 4 parts, that would be 2 in each section. But I split -8. So I should have -2 in each piece of my number bond. So each of these goes back a span of 2, landing at -8. Here's a division statement we could write about this number bond. -8 is divided into 4 equal groups. Another way we can think of it as -8 is divided into groups of -2. The expression for this one, -8 is divided into 4 groups, or -8 is split into groups of -2. In this case, the fact family would result in a -2, and in this case, the fact family would result in 4 because we were able to create 4 groups of -2. Now let's come up with a hypothesis or a conjecture. If you're dividing a negative and a positive together, in this case we ended up with a negative result. When I divided a negative and another negative, I resulted with a positive answer. Here's another picture. This one I have 4 groups of negative 3 is negative 12. So you could think of it as negative 12 split into 4 equal groups, which would give you each piece is negative 3. Or if we split negative 12 into groups of negative 3, we're able to create 4 groups. So again, a negative and a positive divided results in a negative answer, but a negative and another negative divided results in a positive answer. Number 5. Is it possible to model negative 12 divided into 4 groups on a number line? Why? Use the number line to show your thinking. So, a number line represented negative 12 divided into groups of 4 is not possible. If we were trying to do groups of 4, the 4 would point to the right. Which would mean we could not end at negative 12 because we'd be pointing towards positive 12. For problems 6 through 8, create a number line model to show each division expression. Negative 14 can be split into 2 groups. So negative 14 split into 2 groups. Each one has to be negative 7. We're going backward 7 and backward 7, landing at 14. 9 split into 3 groups would be 3, so negative 9 split into 3 groups is negative 3. Negative 10 split into negative 2 groups? No, that doesn't make sense. What about negative 10 split into groups of negative 2? Yeah, that works. So we're going to create groups of negative 2 until we get to 10. And we were able to create 1, 2, 3, 4, 5 of those groups. Here, each of our arrows had to be negative 3. And in this one, each of our arrows had to be negative 7. Remember, we're using those families to help us determine our answer. Here we see 8 divided by 4 is 2. A negative 8 divided by a negative 4 is 2. But a negative 8 divided by 4 is negative 2. So our hypothesis may have something to do with when they result in a positive versus when they result in a negative answer. Here, the signs of the dividend and divisor are the same. They're both negative, and in this case, they're both the same. So if they have the same sign, then we get a positive result. But if they have different signs, one negative and one positive, then our result is negative. Now that rule works for multiplication and division, but keep in mind it does not work for addition and subtraction. When you're adding and subtracting, you have to think about the direction of those arrows and which one is longer. So what do you think in this case? If I have a positive and a negative, should it be positive 2 or negative 2? My signs are different, so my result should say negative 2. Now we're going to rapid fire here. Just tell me if you think the result is positive or negative. How about negative 27 divided by 9? Negative 10 divided by 5? Negative 20 divided by negative 8. Those signs are the same. So think about those conjectures or those hypotheses that we use to help you answer questions when dividing integers.